All right. So then, good evening, everyone. Good evening, everyone. Give me a small reply. Voice is okay. Give me a small reply. Voice is okay. Give me a small reply. Okay. Now today, Monday, gas lows. Today we are doing some questions. We'll do fully. Sometimes today, 7 to 9 o'clock. I'll stop at 9 o'clock for today. Right. 9:30 sometime. Sometimes 9:30. Normally 5 to 9 year after. But okay, today 7 to 9. Today we will do gas laws set of questions today fully. Fully questions today. Fully questions today. Right. Okay. All right. Now right. Okay. Now no break. No break, fully work only today. 7 to 9, sometimes 9:30, maximum 9:30 today. Okay, right. Everyone take your gas low student. Stay focused. Be very active. Be very active. Okay, forget about every problem and every story. Completely erase in your mind and now engage. Be in the lesson. Be in the session. Right? Story. I think last day we were talking about Boyle's law, Charles' law. Last day we were talking about Boyle's law and Charles' law only. Is it only? Right. I want someone to see the note. I thought we have done pressure law, ideal pressure law. I thought like we finished doing pressure law and then combined gas law. And I thought like we finished doing ideal gas equation as well. I think we haven't done. Physical class we finished the story. Right. I want someone to send the last theory note first. After completely finishing ideal gas equation only, we can start doing lots of questions. Right. I want to thank you, Misra Sen, Vishmita Sen. Thank you so much. Okay. Right. Okay. I think we started. We explained Charles' law idea. We explained. Right. Okay. Charles' law idea we explained. Okay. Right, okay, then thank you Anishana and Amani, thank you so much. Okay. Right, okay. Okay, right. Again, theory, that means theory only today. Theory only, not questions. Theory only today, right? Okay, stay focused. Stay focused. Very easy section. Yesterday, now physical class I finished. Gas laws, mainly theories, mainly finished. Have done some questions. Online class, today we are completing somewhat, but by Thursday, by the end of Thursday, we can completely finish gas laws, and I think we can almost complete unitary lenses. Lenses we can almost complete, I think. Almost complete, right? Okay. Now, sir, now we are talking about gas laws. Yes, last day we were talking about Boyle's law. If you briefly explain what is Boyle's law. Sir, Boyle's law, we all know that if there is an ideal gas, this Boyle's law, Charles' law, they are not applicable for practical gases. Huh? The real gases, we can't apply Boyle's, Charles, pressure, any law. All these laws we can apply for an ideal gas. Sir, right, okay, sir, okay, if you are experiencing any issue, please tell me, right, if you're experiencing any issue, please tell me. If you're experiencing any issue, what shall I do? I will join in this tab also. Give me 1 second. If I join in the tab, right, okay. If I rename myself, Suleiman sir. Right, okay. All right. Reply to Suleiman sir if you have anything to be clarified. Okay, right, okay. So then we talked about Boyle's law idea. What is Boyle's law? So we can remember when there is an ideal gas of fixed mass, the mass should be constant. When the mass is constant and temperature of that gas remains constant. When mass and temperature remains constant, then we know that the pressure of the gas is inversely proportional to the volume. That means when the volume increases, pressure decreases. When the volume decreases, pressure increases. That is the Boyle's law idea, right? Then we wrote an equation. Yeah, pressure inversely proportional to volume. That is the logic. That is the law. Pressure is inversely proportional to the volume. This story we learned, right? If I apply this relationship, pressure inversely proportional to volume story for two different states in that gas. Okay, so we wrote P1 V1 equals P2 V2. We wrote P1 V1 equals P2 V2 story. That is the equation. Mainly we are applying under Boyle's law. P1 V1 equals P2 V2. We can write down PV equals constant. You know, we can write down P into V is a constant. We learned last day. Then P1 V1 that is equal to. If I apply Boyle's law for two states, P1 V1 that's equal to what? It's equal to P2 V2. P2 V2. I don't explain what story we learned already. Right, okay. Right, okay. Then next story. If you're experiencing issues, tell me. Second story. Then second we talked about, recently we talked about Charles law. Charles law, I think we haven't drawn any graphs yet, I think. Charles law means same if there is ideal gas, right? When mass of that ideal gas is constant and throughout the scenario we know that we want to maintain pressure. We want to maintain pressure of that ideal gas to remain constant. When the mass and pressure remains constant, we learn when mass and pressure remains constant, then we all know that the volume of the ideal gas is directly proportional to the absolute temperature. I told you what is absolute temperature. That is temperature measured in kelvins. Temperature measured in kelvins, that is what we call as absolute temperature. So we wrote that volume is volume of the ideal gas directly proportional to the absolute temperature capital T. Then V over capital T is a constant. When you apply Charles law for two different states of an ideal gas, we can write down the popular equation V1 over T1. Right, V1 over capital T1, that is going to be equal to what? V2 over capital T2. V2 over capital T2. This story also we learned. I think we stopped from here. I think last day we stopped from here. I think, if I am correct. Am I okay? Right, okay. Hands up, all okay. Connection, everything, all okay, hands up. Sir, sound, voice, video, right, everything is very clear. No any issue, hands up. No any issue, everything is very fine. No issue, hands up. All okay, hands up. All okay, hands up. Superb. Right, okay, nice. Right, okay, nice, okay. Okay, nice, okay. Right, okay. Then I think I will talk about year after. I will talk about next story, the graph stories, no? Today I will talk graph stories, right, okay. Right, okay, today also we'll do theories and we'll do questions. Today we are doing questions, don't worry. Today we are doing questions, don't worry. Right, okay. I'll share the PDF. If you don't have the PDF, if I share the PDF, I thought we completed the ideal gas equation. That was in my mind. Right, it's okay. Sometimes, no, it's okay. It's okay. It's okay. If you don't have the PDF, you all have the tudes. If you don't have the PDF, tell me. I'll share the PDF in the groups. Okay. Right. I shared. All right. All right, me. Very simple story. All right. Very easy. 7:17. Okay. Time is flying for me. I don't know. How about you? Right, okay. I think we have done the test B question also we have done, no? The page number 28 test B question also we have done, sir, but still under, okay, hands up, how many of you came for that? No need, okay, no need to ask like that, okay, no need. Then graphs related to Charles law. Then draw the graph, start drawing the graph, page number 29, draw the graph between volume and temperature, but that is absolute temperature. Draw the graph. Y-axis volume, x-axis temperature, absolute. That means temperature is in kelvins. Start drawing the graph. Everyone start drawing the graph, you try. So y-axis is volume and x-axis is absolute temperature. That means what? Temperature in kelvins. Temperature measured in kelvins. Temperature measured in kelvins. So now answer, finish drawing answer. Graph, this graph is finished answer. First one, first graph done answer. First graph done drawing answer. First graph finished answer, finished answer, finished answer. 6 people finish. Very simple story. Finished. Very simple. Oh, I am not recording the meeting seriously. Not online. Yeah, that okay. I am recording the meeting. Okay, thank God. Recording. I am recording only, right? Okay. Okay, I was so shocked. So then, sir, look here, sir. Look here. We all know the Charles law equation. Charles law equation is what? Volume equals. Volume is directly proportional to absolute temperature. If you convert to equation, volume equals a constant into absolute temperature. This is that Charles law equation. Charles law equation. So according to Charles law equation, you look at your y-axis, right? Imagine V equals K into capital T. Y-axis is what? Volume. Y-axis volume. Volume is y-axis. Volume is y-axis. In this graph, what is the x-axis? Absolute temperature. Yeah, capital T means temperature measured in Kelvin, absolute temperature only, x-axis. X-axis. So then we know that y equals K means what? Gradient. Gradient, this graph going to be y equals mx graph. So very simple, y equals mx graph. Simple. Very clearly, not difficult, very simple. Next graph is somewhat important. Next graph is somewhat important. Again, they are asking next graph. Okay. Okay, right. Now there is one important point. I will ask you one question. I will ask you one question now, right, sir? Now there is an ideal gas. There is an ideal gas, right? When the temperature is decreasing, if you are reducing the temperature, what will happen for the volume of the ideal gas? When the temperature decreases, we all know that volume of the ideal gas also decreasing. When temperature decreasing, we all know volume of the ideal gas also decreasing. Temperature reducing, volume also decreasing. My question is, when the temperature becomes 0 Kelvin, according to the graph, what is the volume? Reply everyone. When temperature becomes 0 Kelvin, what is the volume of the gas? Reply everyone. When the temperature becomes 0 Kelvin, according to the graph, what is the volume of the gas? Everyone knows 0. Everyone knows, according to the graph, when temperature becomes 0 Kelvin, volume of the gas 0. But is it okay? Practically, is it possible for a gas volume to become 0? When temperature becomes 0, they are telling volume of the gas becomes 0. Practically, is it possible for a gas? Now, there's a gas, there are gas molecules. Practically, is it possible for a gas molecules to have 0 volume? Practically, no. Then what does they mean by when temperature becomes 0? What do they mean by volume is 0? What do they mean by when temperature becomes 0? What do they mean by volume 0? Anyone can tell? What happens is when temperature reduces, that gas is converting to liquid. When temperature reaches 0 Kelvin, when temperature decreases to 0 Kelvin, that gas, ideal gas, is converting to liquid. That is the meaning of 0 volume at 0 Kelvin. Do you understand? It's not, that does not mean that 0 volume is, you don't think like, now no gas volume, wrong. At 0 Kelvin, what happens is when temperature reduces to 0 Kelvin, that gas converts to liquid. Red color pen, write down. Red color pen, write down important story, write down. Write down. Write down, red color pen. Write down. Okay, write down. Write down. Tomorrow night there will be one essay question discussion. Okay, write down. Okay. Right, okay. Give me 1 second. Where is that? Okay. Okay. Right. Give me 1 second. One second. Okay. Write red color pen, write down red color pen. Write down. Write down. Okay. At 0 Kelvin, at 0 Kelvin, at 0 Kelvin, comma, the volume of an ideal gas becomes 0. At 0 Kelvin, the volume of an ideal gas becomes 0. At 0 Kelvin, the volume of an ideal gas becomes 0. Full stop. Full stop. This means the gas would theoretically occupy no space. This means the gas would theoretically occupy no space. Full stop. This means the gas would theoretically occupy no space. Full stop. In reality, comma, gas condenses into liquid. In reality, comma, gas condenses into liquid before reaching 0 Kelvin. Very important story. In reality, gas condenses into liquid. Gas condenses into liquid before reaching 0 Kelvin. Before reaching 0 Kelvin. Before reaching 0 Kelvin. Right? Next graph. Next graph. Next graph. Next graph. Okay, next time we want to draw the graph between volume and temperature again, but this time temperature is measured in Celsius. This time temperature measured in Celsius. How should we draw the graph? Okay, right. Look here now carefully. Now carefully listen. Give a try. You guys give a try. Right? Okay. Now we all know that what is the relationship between Celsius temperature and Kelvin temperature. How do we convert? If they have given Celsius temperature, 27 degrees Celsius? How do we convert to Kelvin? If they have given the Celsius temperature, if we want to convert to Kelvin, still I haven't taught the story, but you all know that. Sir, at 273. For an example, if you want to convert 27 degrees Celsius to Kelvin, please add 270. Please add 273 for the 27 degrees Celsius temperature. So we can write down, sir, that means temperature in kelvins, that is equal to what? Temperature measured in Celsius plus 273. Plus 273. Clearly? Right, okay. Then for an example, if you want to convert 27 degrees Celsius, 27 plus 273 means 300. If you want to convert 127 degrees Celsius, 127 plus 273, that is going to be 400 Kelvin. Right, okay. Now this time we want to plot the graph between volume and temperature in Celsius. Right, okay. Sir, okay. Charles law says what? Volume equals, look here, volume equals, Charles law says that volume equals constant into, here capital T means temperature in Kelvin, capital T means temperature in Kelvin, constant into temperature in Kelvin. So we can write down volume equals, from equation 1, volume equals volume of the ideal gas, that is equal to constant into, from equation 1, Tk means what? Tc plus 273. From equation 1 we can write down, from equation 1 we can write down temperature in Kelvin is what? Temperature in Celsius plus 273. Right, okay. What I'm doing actually, now they are asking us to plot a graph between volume and temperature in Celsius. Actually, I don't know the relationship between volume and temperature in Celsius. To plot a graph, remember always, if you want to plot a graph between two variables, my advice is always find an equation involving those two variables. If you want to plot any graph, those two variables in the graph, try to obtain a relationship between those two variables. Then only we can understand what would be the exact shape of the graph. So finally, sir, I involved volume, right, volume and temperature in Celsius. I can expand the bracket. If I expand the bracket, volume equals K into T, a constant, K is a constant, a constant into temperature in Celsius Tc plus 273 into constant, 273 into a constant. Some people think like, right, since the symbol of Kelvin, temperature, Kelvin is capital K, no? Some people think like this as Kelvin, 273 Kelvin, wrong. Here this capital K is a constant, 273 into a constant into Tc. And now I can plot the graph, sir. Y-axis in the graph is volume. Y-axis is volume. In the graph, x-axis is temperature in Celsius. Then this gradient, this K is behaving like a gradient simple limb. Then this plus. This entire people, 273 into K, entire people behaves like a kind of interception, like an interception C. Now I can plot the graph, sir. The way the graph between volume and temperature in Celsius going to be, look here. Volume and temperature in Celsius going to be, that's going to be temperature in Celsius, Tc. Right, temperature measured in Celsius, that's going to be Y equals mx plus C graph. How are we going to draw the Y equals mx plus C graph? Right, this is the Y equals mx plus C graph. Right, forget about this side, left side, don't forget about it, Y equals mx plus C graph. Right, but I extended the graph to the negative direction of temperature, negative temperature axis for a reason. This is how we plot the Y equals mx plus C graph. No issue, easy, no, not a problem, no, very simple, no. Right, okay. Now tell me, in the graph, what is the interception? Reply everyone, what is the value of interception? Look at this story. What is the interception? Reply everyone. What is interception in the graph? In the graph, what is interception? In the graph, what is interception? 273 into K. Not 273, that's the problem. Don't misunderstand. 273 into a constant, not Kelvin. 273 into a constant. That is our interception. Right? Interception is what? 273 into a constant. That means this gap is how much? This gap going to be 273 into a constant K. Right, chemistry also you might learn this graph. I think you can remember chemistry also when you're learning gas laws, you learn this graph. My question is, What is this temperature? What is this temperature? Anyone can tell? This is 0 Celsius. 0 degree Celsius. X-axis is measured in Celsius. Right? This is 0 degree Celsius. I'm asking, what is the temperature belongs to this point? Can someone tell? Anyone can tell? Anyone can tell? Anyone can tell? Minus 273. People are telling minus 273 Celsius. Many telling it's minus 273. Many telling very good. Many says that based on your chemistry knowledge. Everyone says it's minus 273 Celsius. Okay, right? Because axis is marked in Celsius. This is everyone says it's minus 273 Celsius, not Kelvin. It's wrong. Someone is telling minus 273 Kelvin, wrong. But everyone says, very good, it's minus 273 Celsius. Very good, very good, very good. Superb, superb, superb. Right, okay. Right? How can you confirm that? Right? How do you know? Because the chemistry you learn the story. But how do we exactly confirm that is minus 273 Celsius? Let's prove it. This gap is simple x. Tell me, in this volume temperature graph, what is the gradient? Gradient is, we know that that constant k. In the graph, you all know, right? The tan value of the angle, this angle theta, right? This angle theta, right? We all know gradient means what? Tan theta. You guys know that gradient means tan theta. Gradient, that is going to be what? That is going to be tan theta. Gradient means tan theta. Right, according to corresponding angles. Look here, this angle theta means according to the corresponding f angles, this angle is theta, this angle also theta. Clearly, this angle theta. So we all know that tan theta means, if you take this small right angle triangle, tan theta means what? Opposite over adjacent. Tan theta means we all know that opposite over adjacent. Gradient of the graph is, gradient is what? That is constant. Gradient of the graph is, according to the equation, it's a constant k. It's k. Right? Tan theta means we all know that opposite is 273 into k, not Kelvin, into k, a constant, over adjacent is simple x. Adjacent simple x. Then we all know that capital K constant cancel out. So we can realize, we understood x is 273. This gap is how much? The gap between these 2 points is how much? 273. Very simple, 273. Right, then this is 0 means, in order to have a gap 273 in this negative axis, this temperature must be what? Must be minus 273 Celsius. In Kelvin, how much? What is the temperature corresponding to minus 273 Celsius in Kelvin? In Kelvin, tell me, minus 273 Celsius in Kelvin, tell me. Kelvin, how much? Kelvin, how much? 0 Kelvin. Superb. 0 Kelvin. Learn theory properly. That's very important. Learn the theory properly. 0 Kelvin. Very good. This story write down. Or 0 Kelvin. 0 Kelvin. Very good. Very good. Because why? Say the temperature is minus 273. If you add 273, how much? 0 Kelvin. That's all. This story finished. Charles law idea is okay. Next story, special law. Right, I plan to do questions only today, but unfortunately we haven't done that pressure law stories, combined gas law stories, we haven't done. That was a problem. Right? Hands up, who could finish all those hint session questions, hands up. Tomorrow night also we are doing a hint session, tomorrow night. Hands up. Who could do, after giving that hints and all, so I could try all the questions, seriously. I got the idea and final answers, let's check with your answer. When we discuss this Saturday, let's see, but I could do all the questions. I could do, sir. I could do. There are people very happy. Very happy. Don't wait till I upload the recording. Sometimes I upload the hint session recording, I upload sometimes I don't upload. Not a compulsory recording, no. But a compulsory recording, no. Therefore, sometimes I upload, sometimes I don't upload. I don't know. I don't know. I don't know. Right? Next story. Tomorrow, then the remaining questions in that linear expansion, that application story I haven't done. But tomorrow, what shall we do? Liquid expansion. I will give the hints. I could have done that day session till 12 o'clock, but creation issue was there. No? Next story. Next story. Now, I told you this capital K is not Kelvin. Huh? This capital K is the constant. Right? Charles law constant. K is what? Constant. K is not Kelvin. Okay, this K is not Kelvin. It's constant. Constant, 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 constant. If you expand the bracket, constant into capital T C plus 273 into constant. Okay, not Kelvin. Not Kelvin. This is constant. Okay, right. Okay, done. Okay. Then next theory. Next theory. Next theory idea. Right. Okay. Then pressure law. Then pressure law. Next theory. Then pressure law, next theory, right? Okay, write down definition. Definition, write down. Next definition, write down. Write down. Red color pen. Pressure law states that for a given stationary mass. Pressure law states that for a given stationary mass. Pressure law states that for a given stationary mass of an ideal gas. Of an ideal gas. Of an ideal gas. Can't we put, okay, can't we put simple K instead of capital K? Can put constant simple K also can put, no issue. Huh? No issue. I told you what? I told you now. Pressure law states that for a given stationary mass of an ideal gas at constant volume, of an ideal gas at constant volume, comma, the pressure, inside the bracket capital P, close the bracket, the pressure, inside the bracket capital P, close the bracket, the pressure is directly proportional to its absolute temperature. Its absolute temperature. Its absolute temperature. Its absolute temperature. Inside the bracket, capital T, close the bracket. Inside the bracket, capital T, close the bracket. Now story, look here. Right? Very simple. Now, under Boyle's law, we know under Boyle's, under Charles, under pressure, under combined gas law, under ideal gas, what is constant? Mass is always constant. If mass is not constant, we can't talk gas laws. Right now, under Boyle's law, in addition to mass, temperature constant, then the relationship is between who? Pressure and volume. Mass always constant, forget about the mass. Temperature constant means relationship is between whom and whom? Volume and pressure. Under Charles law, mass is always constant, forget about the mass. Under Charles law, temperature constant, relationship is between, under Charles law, pressure is constant. Under Charles law, pressure is constant, the relationship is between what? Volume and temperature. Now under pressure law, under Boyle's law, temperature constant, under Charles law, pressure is constant. Then under pressure law, what must be constant? Volume. Highlight in that definition, highlight, constant volume, absolute temperature. Constant volume, absolute temperature. So when you consider now ideal gas, constant mass, simple limb, and if the temperature, if you notice volume is constant, In that ideal gas, the volume remains constant. We can write down. Then pressure low. Remember, always the pressure of the gas that is directly proportional to the absolute temperature. In an ideal gas, mass and volume remains constant. Pressure of the gas is directly proportional to the absolute temperature. Temperature in Kelvin. So what we can do, pressure equals a constant K into temperature, absolute. This is one equation. Right? Then one can write down, if you bring capital T to the left side direction, pressure over absolute temperature, pressure of the gas over absolute temperature of the gas, that is always a constant. This is the equation. Clearly? Equation okay. Right? Okay. This equation is alright. Okay. Okay. This equation is okay. Now normally we are applying pressure law for two different states of that gas. Normally we are applying pressure law for two different states of that gas. Okay, two different states of that gas. Normally. Look here now, the same gas at two different states. You also write down stories. Now same story. Now state number 1, they say the gas that state number 1, state 1, this one belongs to state 2. State 1, state 2. Simple. We'll do questions. Quickly we'll complete combined gas flow and ideal gas flow. Then finished. Right, state 1, state 2. Now mass is always constant. Then when you notice volume remains constant, then when the gas is at state 1, its pressure and temperature are P1, T1. Pressure and temperature are P1, T1. When the gas is at state 2, second state, pressure is P2 and absolute temperature T2. So then when I apply pressure law, if I apply pressure law, applying pressure law for state 1, you also keep on copying, keep on writing the given spaces, we have to write down. Right, if you apply for this P over T equals a constant for the state 1, P over V is a constant for state 1. State 1, we all know that at state 1, apply. When you apply for state 1, we can write down P1 or V1. Sorry, my bad, P over T. If you apply P1 over T1, that is equal to constant. P1 over capital T1, that's going to be a constant. Equation simply. Apply for state B. If you apply the pressure law for state B, at state 2, we can write down P2 over T2. The pressure is P2, absolute temperature T2, P2 over T2, that is going to be equal to what? A constant K, same constant. Simple B. So we can write down from equation simple A and B, we can write down P1 over T1 is equal to what? P2 over T2. That story. So you can write down simple idea. So we can write down P1 over T1 is equal to what? P2 over T2. Very simple. Simple idea. P1 over T1, pressure over absolute temperature T1, that is equal to what? P2 over capital T2. Story okay. Highlight, very important equation, highlight. That's all. Right, you don't want to learn by heart. Automatically you can remember the stories. If you are studying according to a logic, automatically you can remember these stories. Do you understand? Under Boyle's law, what is constant? Temperature. Under Charles' law, what is constant? Pressure. Under pressure law, what is constant? Volume. Then the relationship between other two variables. Right? When temperature constant, pressure and volume. When under Charles' law, when pressure is constant, volume and temperature. When volume is constant, pressure and temperature. Simple idea. Draw the graphs. Graph story. Graph story. Graph story. Okay. Okay, quickly now graph story write down. Okay, Boyle's law and Charles pressure law done. Right, graph between Charles law ni can draw same graph. If you draw the graph between pressure and absolute temperature, same graph, same shape. You try same shape. So y-axis pressure, x-axis is going to be absolute temperature. Very simple. X-axis temperature measured in kelvins. So then we all know pressure equals a constant into temperature, absolute temperature. So we all know that pressure equals a constant into absolute temperature. Y-axis is going to be pressure. Y-axis is going to be pressure equals gradient is constant m. Absolute temperature is going to be our x-axis. The graph going to be y equals m is graph. So then you can think same way. What is the physical meaning? When temperature becomes 0, pressure of the gas becomes 0. Is it possible? Not possible. When the temperature reduces to 0, the graph shows that at 0 Kelvin, when temperature becomes 0 Kelvin, when temperature reduces to 0 Kelvin, it shows that pressure becomes 0. Pressure of the gas can't become 0. But basically what happens at 0 Kelvin, since that gas reaches the liquid, that is what the meaning. The meaning is that. Red color pen write down. Red color pen write down. I saw the hint session note PDF that you shared in the group and tried the questions. Even if you don't upload the recording, please send the PDF. Normally I say no. I will upload the recording. I don't know. It depends on my mood. Right, I will upload. It depends on my mood. Let's see. Aren't we seeing moles? Sir, aren't we seeing moles? What do you mean by aren't we seeing moles? The point is given, no? At 0 Kelvin, the pressure of an ideal gas becomes 0. This means the gas molecules stop moving. This means gas molecules stop moving. But in reality, gas molecules, gases condense into liquid before reaching 0 Kelvin. The highlight entire sentence. They can ask one MCQ point. They can ask you from one MCQ point. Given, no? Right, okay. Then next story, next graph. Draw the pressure graph with Celsius temperature. Right, same story. You try same story. Same graph, same shape. So therefore what I am doing, I am drawing the graph in here. Same story, same graph. We all know that pressure law says what pressure equals constant into absolute temperature, means temperature in Kelvin, then pressure from equation 1, Kelvin temperature means Tc plus 273, right? Then pressure in Kelvin, Tc 273 into K, then same graph, pressure, y-axis pressure, x-axis temperature in Kelvins, right? Right, same story. But you do properly once again. Entire story write down properly once you are finished answer. Same story write down properly once you are finished answer. If you are done answer, right, can be finished. If you are done answer, done answer. So PV equals nRT, n is moles. We saw when temperature, pressure and volume is constant. Aren't we seen for moles? That means when moles are constant. We saw when temperature, pressure and volume is constant, aren't we seen for moles? That means when moles are constant. If the mass of a gas is constant, means number of moles in the gas is constant. Right? I don't know what you mean by that story. If the mass is constant, means the meaning is, if in a gas, mass constant means the number of moles in that gas is constant. I don't know what you are coming to, girl. I don't know. Okay, finished answer. Right, then we can talk about combined gas flow story, then story finished. Then I will teach you ideal gas equations. And how many of you in this class IT hands up? ICT hands up. How many of you in this class doing ICT hands up? How many of you doing the class ICT hands up? No one? Only one? Then easy. Then I don't want to explain what is moles and all, no? Okay, right, okay. Then next topic, finish doing, no? Finished answer. People who finished answer, finished writing. If you finish answer, finish writing answer. Okay, right, okay. Then write down next story. Next story, combined gas law. Combined gas law is important story, important idea. Combined gas law. Right, okay. Combined gas law story, okay. Look here. Now, combined gas law theories, right? Combined gas law theory. Not difficult, can do. Combined gas law theory is next story. Combined gas law. Combined gas law, okay. By the name combined gas law means what? It is combination of what? Boyle's law and Charles law. Combined gas law. Combine means what? It's combined Boyle's law and Charles law. Boyle's law and Charles law. Right. If I explain this idea, now there is a gas. There's a gas. There is a gas, ideal gas. Mass is simple limb. Initial pressure P1. Initial pressure P1. Then volume V1. Temperature, absolute temperature T1. Okay, absolute temperature T1. Right, okay. Then, right, this is a kind of, now actually this is state number 1. There's an ideal gas at state number 1. Right, then this ideal gas converts to state number 2. Right, there's an ideal gas, mass constant, it is at state number 1 and it is going to convert into state number 2, second state. Right, state number 2. This is a kind of intermediate state between state 1 and state 2. This is kind of intermediate state. Right, between state 1 and 2. Okay, right, okay. Right, okay. Idea somewhat okay. Right, okay. Now what happens? Now very careful listen. Now pressure. When this ideal gas at state number 1 is reaching the intermediate state, its pressure is now P2. Pressure is P2. Its volume is, let's take its volume is V dash. But temperature is same as capital T1. Temperature same as capital T1. Okay, very simple. Now that's an ideal gas at state number 1. It is converting to state number 2. This is a kind of intermediate state between state number 1 and 2. Okay, right? Okay. Then when this ideal gas moving from intermediate state to state number 2, temperature changes to T2, volume changes to V2 volume, pressure is same as P2. Now when you carefully observe state number 1, when the gas is at ideal gas at state number 1 and when you consider carefully intermediate state, Which law we can apply? When you consider state number 1 and intermediate state, which law we can apply? Reply everyone. Which law we can apply? From between state number 1 and intermediate state, which law we can apply? Which law? Boyle's law. Why? Because look here, state 1 and intermediate state, mass and temperature remains constant. Mass simple limb, temperature T1, T1. Then pressure changes P1 to P2, volume changes to V1 to V dash. So we can apply Boyle's law. Boyle's law. If we apply Boyle's law, Boyle's law from state 1 to intermediate state, apply. Just apply. Write with me. Applying Boyle's law for state 1 and intermediate state. State 1 and intermediate state. Intermediate state. Apply Boyle's law. If you apply Boyle's law, give a try. Apply. So we all know that applying Boyle's law. Applying Boyle's law, P1 V1 equals P2 V2. Applying Boyle's law, P1 V1 equals P2 V2. Apply. P1 V1 equals P2 V2. Then state 1 pressure and volume is P1 V1 only, but state number 2, so the intermediate state pressure is P2, volume is V dash. So P1 V1, that is equal to pressure is P2, volume is V dash. What shall I do? I write this volume V dash in different color. Different color, volume V dash. Okay, no issue, no. Beautiful, no issue, beautiful. Shall I substitute V dash for a reason? Right, for a reason, since I have done this story multiple times, I will substitute V dash for a reason. If I substitute intermediate gas volume, that is going to be, we all know, P1 into V1 over P2, equation number, Roman number 1. Equation Roman number 1. Okay, no? Clearly? When you consider the conversion of gas from intermediate state to state number 2, which law we can apply? If you consider intermediate state to state number 2, which law we can apply? Which law? Which law we can apply? Which law? Which law we can apply? Which law? Charles law. Charles law. The reason is what? The reason is we notice, look here, when you consider intermediate state and state number 2, look here, mass constant, pressure constant, P to P2. Mass constant, simple limb, pressure constant, P to P2. So we noticed volume changes from V dash to V2, temperature changes from T1 to T2. So we can apply Charles law for the conversion from intermediate to state number 2. Charles law. Charles law. Apply. If you apply Charles law, I write here, theory, okay? Right, we'll do some difficult questions also today. 8 o'clock. 8 o'clock, 1 hour finished. 8 o'clock, 1 hour finished. 8 o'clock, 1 hour finished. Right? Okay? Intermediate state and state 2. Intermediate state and state 2. State 2. State 2. Apply Charles law. If you apply Charles law, applying Charles law, apply. Applying Charles law. Then V1 over T1 is equal to V2 over T2. If you apply V1 over T1, that's going to be equal to what? V2 over T2. Apply. Please write these stories properly. Write down properly, nicely write down. Always, your note must be very beautiful, okay? Right, your note was very beautiful. Write the story properly. V1 over T1 is equal to V2 over T2. V1 over T1, that is equal to what? V2 over capital T2. Right, then intermediate state volume is V dash T1. V dash over T1. Right, V dash, volume is V dash ni. V dash over T1. Then state 2 volumes are V2 T2 only. Right, okay. V2 over T2. So we can write down from equation Roman number 1. From Roman number 1 we can write down V dash means what? Roman number 1. According to Roman number 1, V dash means we all know that that is P1 V1 or P2. V dash means we all know P1 V1 over P2 according to Roman number 1 over capital T1 V2 over capital T2. So now I can do something. What if I move this P2 to the right side? Then we can write down beautiful equation. So P1 V1. So P1 V1 over capital T1. That is equal to what? That is equal to P2 V2 over capital T2. This is what we are calling as combined gas law. Very simple, combined gas law equation. These are standard equations you can apply directly, right? You can apply these equations directly for the questions, right? Directly for the questions, right? Okay. What instant we can apply combined gas law? If you are noticing, right, whenever there's a phase change from 1 to 2. Sorry, if you're noticing whenever there's a state change from 1 to 2, look here. If you're noticing that gas samples pressure, volume, temperature, everything is changing from state 1 to state 2. In Boyle's law, we know that temperature constant, only pressure and volume changed. In Charles' law, we know that pressure is constant, both the scenarios, both states, pressure constant, only volume and temperature varied in that gas. Under pressure law, we know that volume is always constant. In state 1 and state 2, volume is same, but we know that only pressure and temperature varied. But in this scenario, in a gas, if you notice state 1 to state 2, if you notice pressure, volume, temperature, everyone changing, all those variables changing, you want to apply only combined gas law. Right, okay? Very simple story, finished answer, very simple story, finished answer, right? Application of pressure law to two states of an ideal gas. Under that topic only, you want to write down this story. Right, this diagram and this story, you want to write down under that topic only. Application of pressure law to two state of ideal gas. Got it? No? Clear, no? Right? Clear, no? Okay, right, okay, done. Nice, no? Very easy. Now we can do some questions also. Combined gas also done. We'll do ideal gas equation also and we'll do questions. We'll do ideal gas law and we'll do questions. So ideal gas law is the best equation. Okay, we'll do some questions for our fun. Okay, for our fun, but difficult questions. Don't judge yourself. Right, difficult questions only. Right, but can learn a lot. Go to page number. Okay, go to page number. Okay, today, okay, nice question. Difficult question. Suddenly it's a difficult question, not easy question, okay? It's difficult only, seriously difficult. Difficult only. Hmm. 65, page number 45, question number 65. Page number 45, question number 65, difficult question. Page number 45, question number 65. Page number 45, difficult question. Question number 65. Chemistry, you might have done the stories in chemistry, right? Okay. I sent a message but you didn't reply. I'll reply, girl. I was in a class actually. Okay. 5 p.m. onwards, I am in a class. Okay, that's why I reply. Okay. Then after 65, 70 is also very basic question. 70 is very easy question. 70 is easy. 65 is a bit difficult. Okay, what you do 70 first? Okay, do 70 first. Look here. Try 70 first, then 65 second. Difficult. 70 first, 65 second. Then try a difficult question is there. Lake story 74. 74. 74. Apply suitable boil salt, charcoal soap, pressure or combine. Apply those for and do these 3 questions. Very easy. This is easy. This is somewhat complex. You should know the hydro theories and 74 idea. Give a try. I'll give small time, not big time, small time. Any gym in the class done 70 hands up. 70 done hands up. Any gym in the class done 70 hands up. Gym in the class done 70 hands up. No gyms yet. Those gems are growing. They yet to come. They yet to come. Right? They are doing. They are doing. They are doing. Give a try. But remember, after I give the hints, if you can do the question means you are really in a good level. Huh? After I give a somewhat, but upcoming days I am not giving hints with the time. From that my hints, if you can do a question means the last answer, you are very good. You are good. 1 finished. 72 finished. Right, 72 finished. Very simple. 3 finished. 3 finished, 70. 4 finished. 4 finished. 74 finished. Keep on doing remaining questions. Nice questions are. They're not very superb questions. So when can we apply combined gas law? Can you tell again? When we can apply means when you notice all 3 variables. Pressure, volume, temperature, all 3 varying. All 3 are varying. Pressure, volume, temperature, all 3 are varying. You can apply combined gas law. Chemistry learn no? Very easy. I am doing 70. 70 I am doing very easy. Any gym in the class. Okay, I think everyone can do 70. Everyone can do 70. Very simple question 70. 70 is very simple question. 70 very simple question. I am doing 70. 70 story and air volume of 80 centimeter cube at 20 degrees Celsius is heated to 100 degrees Celsius, constant pressure. A constant pressure, when they tell constant pressure, what law? What law? Charles law. When they tell constant pressure, same mass means Charles law. V1 over T1 equals V2 over T2. 70. 70, sir. Now look here, they are telling what, sir? Normally when I am doing, I am drawing a diagram and I am doing, but no need. Diagram is not important. When you do, don't draw a diagram, but I draw a diagram for my fun. For my fun, I am drawing a diagram. An air volume of 80 centimeter cube at 20 Celsius. Right, temperature is what? T1. That is 20 degrees Celsius. T1 is 20 degrees Celsius. Air volume is 80 centimeter cube. V1. Air volume V1. V1 is 80 centimeter cube. Clearly? Right. The second state. Heated to 100 degrees Celsius. Now temperature is 100 degrees Celsius. T2. 100. They are asking what T2 is 100. They are asking new volume. What is the new volume? V2. I want to find V2 actually. But they clearly mentioned that air, gas, air, pressure is constant. They clearly mentioned, nice story, pressure is constant, capital P, capital P. When pressure is constant, sir, the temperature and volume only varying, the story is Charles law, sir. Charles law. Applying Charles law. Applying Charles law. Charles law, sir, V1 over T1 equals V2 over T2. Charles law. Apply V1 over T1, that's going to be equal to V2 over T2. Right, V1 over T1, that's equal to V2 over capital T2. Now here you can convert centimeter cubes into meter cube, no issue. But look here, now you can convert centimeter cubes into meter cube by multiplying by, how to convert centimeter cube into meter cube, multiplying by 10 to the power minus 6. But think practically now, left side also volume is there, right side also volume is there. Right, therefore even you convert to meter cube, that minus 6 cancel out. So therefore what you can do, you can substitute in centimeter cube itself. Then you get the answer in centimeter cube. That's all. It's up to you. It's up to you. I am substituting centimeter cubes. 80, but temperature must be substituted in kelvins. 20 degrees Celsius, how to convert to kelvins? Add 273. When you add 273 plus 20 is how much? 293. Okay. Definitely want to substitute temperature in Kelvin. Definitely in Kelvin. I want to find V2 volume. V2 volume. If I want to find V2 volume, temperature is 100 degrees Celsius. How to convert 100 Celsius to Kelvin at 273? 273 plus 100, 373. 373 when I substitute V2. If I substitute V2, I'm getting the answer what? If I substitute V2, this V2 is equal to what? V2 is equal to 373 into 80. V2 is equal to how much? 373 into 80. Okay. 373 into 80. Into 80 into 80 over 293 log simplification. Log simplification, log value. So everyone tell me, take your log books. Now remember, now when you are joining online also, remember you should have a logbook with you. If you don't have, quickly run and take a logbook and come quickly go and come. Meantime, someone tell me log value 373, 373 log value 2 point, log value 2 point, 2 point. Then who told? Shada told 5717. Someone cross check. Someone cross check 5717. Log value of 80, 1 point. Log value of 80, 1 point. 80 log value. Hana 9031. 9031. Want to add them together. If we add them together, these two add them together, sir, now here 7 plus 1, 8, 3 plus 1, 4, 7, 9 plus 5 is 10, 14, 2, 3, 4, 2, 3, 4, if I'm wrong, tell me, so 8, 4, 7, 14, 2, 3, 4, log value of 293, 2.293 log value. Mishra, 4669. 4669. 4669. Right ni? Okay ni? Simple ni? Simple idea. Simple idea. Simple ni? Right, okay. Now I want to subtract. Subtract here it's 9. Here 3 ni? 3 means if I take 1, 13. 13 minus 6 is how much? 7. 7. Here 0. Here 0. Here it's 2. If I cross check here 18. 18, 7, 8, 14, 7, 4, 4. Anti-lock. Anti-lock. 10 to the power 2. Anti. Tell me anti. 79 anti. 79 anti. 79 anti. Someone tell me. What is the anti 79? Right? Misra. 10, 0, 1, 9. 10, 0, 1, 9. Different answers, no? 10, 0, 1, 8, 10, 0, 1, 7, 10, 0, 9, 1. Everyone go and tell me the answer. I'm getting multiple answers now. 10, 0, 1, 9, 10, 0, 1, 8, 10, 0, 1, 7, 10, 0, 1, 6. Excuse me. Everyone tell me the answer. Okay. Reply hands up. Okay, now remember now. Everyone should need to do. I know that when some people they tell me the log value, others they don't do nothing and they just stay. It's really bad quality. It's not a good quality, it's really bad quality. Imagine it's really bad quality. It's a bad quality. Hands up, the answer is what? 10, 0, 1, 9 answer. 10, 0, 1, 9 answer. What is the answer actually? 8:15. Hands up, it's 10, 0, 1, 9 answer. 10, 0, 1, 8, 10, 0, 1, 8, 10, 0, 1, 9. 10, 0, sorry, so not 10, 0, 1, 0, 1, 0, 1, 9 answer, 1, 0, 1, 9. 1, 0, 1, 9 answer, 1, 0, 1, 9. 1, 0, 1, 9 answer, 5, 6, okay. 6 telling 1, 0, 1, 9. I'm going with that answer. Therefore, the answer is what? 1, 0, 1, 9. Answer is how much? 101.9 centimeter cube answer. Very simple. Right, this question is anyone can do. Simplification simple. Any gem in the class? Any gem in the class done question number 65 answer. 65 done answer. 65 done answer. Any gem in the class? 65 finished answer. There are people. There are 3 people. There are 3 people finished. 4 people done. Superb. No. 4 done. No. 4 done. What are the answers? Okay. Okay. There are so many. 1, 2, 3, 4, 5, 6 finished. My answer is answer of any gem got 60 answer. 60 meter answer. 60 meter hands up. Okay, done, try it. It's superb. 60 meter hands up. 60 meter, 2 people. Very good. Superb. Not 2 people also, 1 people. 61 people also, very good. Superb. Huh? Very good. 60 meter, very good. Very good. Now, but the people who tried the question and got an answer, very good. People who got the answer, we good. Very, very good. Superb, no? Trying is number 1, superb. No. If not, we'll tell this. Okay, people who tried and got the answer, we good. People who got the answer, very good. Okay, no? That's better. Question number 65. 65 story. They are telling what? They are saying nice story. They are telling nice question, but you need hydrostatic theories. Okay. The volume of an air bubble released from the bottom of a pond is 1 centimeter cube. When it comes to the surface, it takes a volume 7 centimeter cube. Find the depth of the pond if the atmospheric pressure is 10 water meters. Okay, pond story. So now there is a pond. There's a pond. Right? There's a pond, there's a water. There is an air bubble at the bottom. When the air bubble reaches the top water surface, free water surface, right, they mentioned volume of the air bubble is 7 centimeter cube. When the air bubble is at the bottom, volume is 1 centimeter cube. In the air bubble, what is inside? Air ni, gas ni, Inside gas is there, air is there, air. Right? Let's say now when the air bubble is at the bottom, volume is V1. Right? Pressure is P1, volume is V1, pressure of the air inside the bubble is P1. P1. Right? So V1 means they have given 1 centimeter cube. Pressure, I will come to pressure story in a while. Pressure story will come in a while, okay. Volume V2 volume 7 centimeter cube. V2 volume, right? I do log simplification only one time. I am expecting everyone to tell the right answer. Every time I can't erase and I can't do it, right? Therefore, I do only one time. Majority, at least everyone should try the log simplification and they should tell the final answer. But normally, very same typical people are sending the answers. I don't know. I don't know. 7 centimeter cube. Right? Okay. Right? Okay. So now the problem is pressure. Now they haven't given any story for temperature. Remember, you want to assume like temperature remains constant. When the air bubble is at the bottom or top doesn't matter. You want to assume like temperature remains constant. You want to assume temperature remains constant, same temperature. Then we know that the temperature remains constant. Air bubble, no, same air mass, same temperature. Then what law? Temperature remains constant means same air mass means what law? Very clear. P1, V1, P2, V2 means Boyle's law. Want to apply Boyle's law. In the question they are asking what? Okay, want to apply Boyle's law only. What they are asking is in the question. They are asking, find the depth of the pond if the atmospheric pressure is 10 water meter. In physics we learned I think last day also I asked you how to convert water meters to pascals. You know that if you want to convert water meters to pascal in physics, hydrostatics we learned. If you want to convert water meters to pascals, what you want to do? You want to multiply by rho g, density of water into gravitational acceleration. That means 1000 into 10. Therefore, want to multiply by 10 to the power 4. If you want to convert water meters to pascals, multiply by 10 to the power 4. They have given atmospheric pressure pi. Atmospheric pressure is how much? 10 water meter. So 10 water meter means if I want to convert to pascals, want to multiply by 10 to the power 4, sir. Then basically that's going to be atmospheric pressure is, we all know that is about 5 pascal. Same answer. About 5 pascal. Same answer. Atmospheric pressure is what? About 5 pascal. Same story. Nice, beautiful. Beautiful. Then tell me, when this air bubble is on the water surface, when the air bubble is on the water surface, what is the pressure of air? That is equal to atmospheric pressure. When if you are the air bubble, when you are on the water surface, the pressure experienced by you is only the air pressure. Only the atmospheric pressure, no. Only the atmospheric pressure. Therefore, very clear, pressure is P2 means how much? Pressure of the air bubble in the free water surface how much? That is atmospheric pressure, 10 to the power 5 pascal. Beautiful, no? It's beautiful, nice only, right, okay. Okay. The problem is, everyone tell me, I want to find the depth of the pond. Everyone tell me, in terms of H tell me, everyone, give a try, yeah? What is the pressure of the air bubble at the bottom? What is P1? In terms of H tell me, what is P1? What is the pressure of the air bubble at the bottom? Everyone tell me. Hydrostatics theories. It is, now this is not gas laws now. Now it is story. What is the pressure of the air bubble at the bottom? It's hydrostatics. Dekho bol. But everyone won't say properly, huh? What is the pressure of the air bubble at the bottom? This is hydrostatics theory. The many saying H rho g, but it's wrong. Right, guys? Students? Right, I am not getting a good answer. I got an answer from Amani. She is good. Amani girl's answer is good, very good, superb. Right? Okay. right? Then Mariam also correct. Mariam only also correct. Good try. Okay. Right? H rho g plus 5. H rho g plus 5 ni. H rho g plus 5. Very simple ni sir. Imagine sir now, if I am the air bubble, if I am at the bottom sir, above me there is water column of height simple h, above the water column there is atmospheric pressure pi. Right, on top of me, water as well as atmosphere is there, therefore the pressure experienced by myself is what? H rho g plus pi. Then P1 is, we all know that H rho g plus pi, very simple. That's all. Small maths. H rho means density of water. If they have given the density of water, we can take it as 1000. H rho g plus pi is what? Atmospheric pressure 10 to the power 5. That's all. Now if I want to find H, we can apply Boyle's law. Apply Boyle's law. P1 over T1. P1 over V1. So P1 into V1 equals P2 into V2. That's all. Right, based on that idea, now I want everyone to do this idea I am getting. I want everyone to get the answer for 74. Be very careful. 74 seems like Boyle's law, but not Boyle's law. Be careful, huh? Very careful, okay? Be very careful. Select the right law. Select the right law for the 74. Sorry, 74. Yeah, 74. Get the answer, huh? Then if I apply P1 V1 equals P2 V2. Nice questions. Nice questions, okay? Learn something. P1 V1 P2 V2. P1 V1 P2 V2. Right. Okay, I'll get the answer in a little small story. Sometimes I talks no. Normally I'm talking no. Now normally I'm talking. Right, P1 means what? H. 10 to the power 3 into 10 is how much? 10 to the power 4 ni. So H into 10 to the power 4. H into 10 to the power 4 plus 10 to the power 5. The volume is what? The volume going to be V1 means what? Yeah, you can convert to meter cube, okay? Centimeter cube can convert to meter cube. Then equal P2 into now 7 centimeter cube also convert to meter cube. Then minus 6 minus cancel out. Because of that, I just substitute centimeter cube, okay? Right, therefore 1 centimeter cube that is equal to P2 pressure is 10 to the power 5 into volume is 7 centimeter cube. That's all. Only equation involving only H can get the answer very easily. Now some people, look here now what you do. Some people don't know when there are powers, they don't know simplification. Normally what I do, I try to convert all the terms having same power. I am trying to convert all the terms having same power. If you convert 10 to the power 5 into 10 to the power 4, if you convert 10 to the power 5 into 10 to the power 4, how much? 10 into 10 to the power 4. Am I correct? Am I correct? If you convert this term into 10 to the power 4, if you convert this term into 10 to the power 4, 10 into 10 to the power 4 into 7. 10 into 10 to the power 4 into 7 means 70 into 10 to the power 4. Simple, ni? Then 10 to the power 4h. Learn those small simplifications. 10 into 10 to the power 4, this is ni. That is equal to how much? 70 into 10 to the power 4. Am I correct? Since all the terms having, there are 3 terms ni. There are 3 terms. Since all the terms having 10 to the power 4 power can cancel out. Sir, remaining is h plus 10 equals 70. Sir, h plus 10 equals 70 ni. H plus 10 equals 70, sir. When you subject h, 70 minus 10 is 60. 70 minus 10 is 60 meter. Nice question. Real nice question, sir. Nice question. Really good question. Nice question. Superb. Nice, no? Beautiful, no? Beautiful story, sir. Beautiful. Right? Okay, no? How many of you doing 74 answer? How many of you doing 74 answer? 74 doing answer. 74 doing answer. 74 doing answer. Okay, you are doing. I'll give small time, but be very careful. Select the right law. They are talking about diameter. You can think like bubble as a sphere. Diameter, sphere. Volume is what the equation you guys can remember. Diameter, sphere. volume of a sphere is, you know the equation, right? Okay. Now I will tell you one story. Now there are people among you, right? There are people among you. Always, always there are people among you always underestimating yourself, right? Right? You guys do while doing a small gossip. There are people among you always underestimating yourself. Right, for an example, you are trying a basic simplification, right? Especially you feel this type of story when you are in a physical class only. Sometimes in your school, sometimes even you are doing self studies also. You are trying to sometimes right now also. I gave a question. I asked you to do 65. Then you are trying the question, right? Sometimes after I done the same question, you are doing in a different way. You are putting all simplification in a mess and you are putting a long simplification and you are doing. Right, then parallelly I am also doing the same question, but I am getting the answer very quickly by following very few number of steps. And there are some people among you, they get fed up. Right, especially this happens, especially boys also same, but mostly girls, right? Right, they are underestimating themselves, right? Then they start to think how I am a fool, how I'm what kind of fool I am. That's how they start to think, right? See, sir could done this step in 4 steps, but I even can't do this question. Even I have done how many simplification steps. Then I am not a good one. I am really bad one. I can't do. Right? They give up, right? Then they always putting down every time when they could not do a simplification, when they could not do a question, every day now mentally they are going down, right? There are people among you also. Don't be like that. Every day, sometimes their all result is very good. Sometimes they are all result is very good, but they normally people have good all result, maybe 6 above 5, okay, think like that, above 5. They should have a very good confidence. No? They are doing A levels, they should do A math science with very big confidence. No? Even they got 8 A's or 9 A's or 7 or 6 A's, even they could not do a simple basic simplification, they get fed up, and day by day, they start to believe that they are not suitable of doing A level math science. Day by day. It happens for some time. They also try, but sometimes no matter how much they try, every day they can't do a simplification, they don't know. Sometimes basic simplification. This cutting story. Right? This simplification some people can't do. Then they start to believe they are kind of fools. They are not good at doing math science. They can't do maths at all. Don't be like that, okay? Don't be like that. No matter entire society come and tell you are a fool, you are a stupid, you can't do this math science. Don't listen to anyone. Every mistake, every silly mistake, every foolish mistake, learn something and keep on moving. Okay, close your ears like this and keep on moving. If you don't believe yourself, because I'm telling this reason for a reason, if you don't believe yourself, no point. You should believe yourself. No? Right? Be very careful. Huh? There are people among you, sometimes basic simplification can't do, give up. Can't do, give up. Can't do, give up. Right? Can't do, give up. Okay? That story, okay? Always trust yourself. Always think that I am with you. Right? Always think that I am with you. You can reveal all your stupid, silly mistakes to me. If it is possible, I will guide you. Right? Learn something. In case if you don't know the simplification, take a note and write down. When there are terms like this is how we want to cut. And continuously look at that simplification mistake again and again. That's how improving. Okay? Because I noticed among you. Okay? Right. Hands up. 74 done, hands up. 74 done, hands up. 74 done, hands up. 74 finished, hands up. There are 4 people finished. 4 done. There are 4 done. There are 4 done. There are 4 done. There are 4 done. 4 done. 3 done. 3 finished. 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 2 finished, not 3, it's 2 finished, I think. No, it's 3 finished actually. It's 3 finished actually, I think. Don't hate any subject, huh? All subjects want to love equally. Okay? Right? Can't hate any subject. Every subject love. Please don't say this loudly. I want to know. Chemistry teacher at Royal College, when you are studying. Right, yeah, I think your school teacher came, no, Ranjan sir, no? I learned from him also. He is one of our chemistry teachers. Very good teacher, but very rough. But good. But I don't understand anything. But he is good. I couldn't understand anything. But he is good. Please give me a timetable. I am going down in physics. I can literally feel this course. I am improving in chem. Now, like, I hate physics. Oh God, yo, what to do? How to give timetable? I want to. Lots of things are coming. Okay. Last one. What was hated subject for you when you were doing A levels, sir? For me, it's chemistry. And one telling. Nowadays, I am started to love chemistry, and I am started to hate physics. One telling like that. Other one telling, for me, it's chemistry. For me, I am hating chemistry. One is telling I am hating chemistry. One is asking what was the hated subject for you when you were doing A levels. Right. Another one is telling. Another one is telling. I hate chemistry these days. Okay. Right. Okay. I hate chemistry these days. You know that when I was doing A level, I don't know combined maths actually. Right, I hate combined maths. My favorite subject was that is chemistry only. The very favorite and most easy subject is chemistry only. Second easiest one is physics for me. Not easy, right? But I hated combined maths not because of maths, not because of I don't understand, because of the teacher actually. That means he was the best teacher. Still, he is the best teacher in combined maths. But what happened was in that class, normally everyone of bright students only going to his class because he was still is very popular. But he's a good teacher, superb teacher, very good teacher. Combined maths is the best. But normally, since all students are coming to his class, bright students only. Every year, Island 1 to Island 10 is in his class. Our period for the last 14 years when we were doing A-levels. Right? Therefore, all our bright people only going to that class. Now, I am not a bright guy. Then he used to tell that always he is demotivating. He is telling, normally singing class is telling, Tamusala me ganවත් කරගන්න බැරි නම් අනිවාර්යෙන් උඹලා ෆේල් වෙනවා උඹලා අනිවාර්යෙන්ම උඹලා ෆේල් වෙනවා උඹලට හරියන්නේ නැහැ උඹලා වැඩක් නැහැ උඹලත් වගේ ගොන් තකතිරු මෝඩ බූරුවෝ නැහැ තමුසලට හරියන්නේ නැහැ ඵලයන් මොකද ආර්ට්ස් කරපන් තමුසල හරියන්නේ නැහැ. Then when if we could not do a question, if you could, sometimes I write, sir, give 5-10 minutes to do a question. I don't know how to get the question. I just keep on thinking. I could not even write one sentence, one line. Seriously. Right, then he starts to tell, not directly to me. Common is saying, huge crowd is there. උඹලට ඔය ගානවත් කරගන්න බැරි නම් උඹලා ගිහලා ඵලයන් ගිහලා වෙන මොකක් කරේ කරපන් තමුසලා හරියන්නේ මැච් කරන්න. That's how he told. Every time he is demotivating middle average people. sometimes below average people. Then automatically for me that only happened. Automatically I didn't want to do maths, combined maths. Because normally other subjects I worked hard, combined maths I felt put a kind of resistance to do work and all. Right, because every day there is demotivating and demotivating pro. Bright people, she is loving it. All the bright people are coming to this class only. Right, me people like me, then I want, right, for me, daily demotivating. Sometimes I could, sometimes I'm really bright one. Because it's demotivating, automatically I was losing the gap. Right, the gap between combined maths and me went big. That's what I meant. Okay, right. 43 is question. Is question. Is question. Is question. Right. How come people love chemistry? Chemistry is a very beautiful subject, no? Very easy subject, nice subject. Not like physics. Physics is very serious subject. It is very serious subject. Okay, no. Then next story. Next story, question number 70 what? I told you to do 70 what? 74. The last question mostly today. Today I am stopping a bit early, okay. The last story. But no matter what others just tell, I am also kind of fool, no? Right? No matter how that teacher also, no, I also kind of fool. Now I think about my past, my A-level, my character, how I was a fool. Right? Just because others, even teachers also, they demotivate, why should I listen to them? It's okay. It's okay, right? Okay. The last question, story finished. Last question, give me 1 second. Finished answer, got the answer, answer. Got the answer, answer. Got the answer, answer. Got the answer, answer. Where's the PDF? Got the answer, answer. Most of you got the answer. Very good, no man. 10 people got the answer. Sounds good. Sounds good. 74, no? It's 74, no? I told you to do. It's 74, right? 74. When the temperature at the bottom of a lake is 7 degrees Celsius, pressure in the air bubble with a diameter of 4 centimeter is 2.8 atm. Find the diameter of the bubble if the temperature is 27 when it comes to the surface of the lake. Very, very easiest than this one. Lake story only. Question number 74, lake story only, air bubble story only, free water surface, free water surface, free water surface, right? And then at the bottom, air bubble at the bottom, then coming to the top. Air bubble at the bottom, come to the top, top, top. Right, this time they mentioned temperature difference. When the air bubble is at the bottom, they mentioned the temperature is how much? Temperature T1, pressure P1, volume V1. At the bottom, temperature is how much? 7 degrees Celsius. Pressure is 2.8 atm. 7 degrees Celsius. Pressure is 2.8 atm. You know how to convert to pascals? Atm means what? 1 atm means 10 to the power 5 Pascal. Volume, they haven't given the volume, but they have given the diameter. Diameter D1, right, since they have given the diameter is what? 4 over 3 for a sphere. If they have given the diameter to the volume, 4 over 3 pi r cube. 4 over 3 pi r cube. Diameter is how much? 4 centimeter. Radius how much? Diameter 4 centimeter means, diameter D1 is 4 centimeter means, radius how much? Radius 2 centimeter. Then you can convert to meters if you want. Okay, if you want, you can convert to meters. Okay, whatever. You can keep in centimeter cube also. It's okay. If you convert to meters, you can convert to meters also, no issue. But I keep in centimeter cube. 4 over 3 pi r cube. 2 centimeter cube. Clearly, clearly. Right, okay, so look here we noticed in this scenario, pressure, temperature, volume, all three given. All three given when the air bubble is at the free water surface, temperature is 27 degrees Celsius, temperature 27 degrees Celsius temperature, 27 degrees Celsius temperature. Pressure is they don't want to give the pressure. When the bubble is at the free surface, the pressure going to be atmospheric pressure 1 atm ni. Pressure is 1 atm ni. It's 1 atm ni. It's 1 atm. Right, they are asking, I think, the diameter only, I think. Find the diameter of the bubble if the temperature is 27 when it comes to the surface of the lake. Right, want to find the volume. Right, want to find the volume. Let's say now diameter d2. Now diameter d2. Right, then volume is what? Now volume of the bubble is what? 4/3 pi. Diameter d2 ni. In radius how much? The 4/3 pi r cube. Radius cube. If the diameter is d2. Radius how much? d2/2. Ni diameter over 2 is radius. d2/2 cube. Cube ni. What is the law? So now here we are noticing same mass but pressure changes, volume changes, temperature changes. All three changes means what law? Combined gas law. Combined gas law. Combined gas law, sir. Sir, combined gas law. Combined gas law. Combined gas law. P1 V1 over T1 equals P1 V1 over T1, that equals what? P2 V2 over T2. Clearly, what's my P1? P1 is 2.8. Want to convert? You can convert to pascals if you want, but no point because it's cancelled out. 2.8 volume is 4/3 V1, 4/3 pi radius 2 centimeter cube over temperature. Over temperature. Right, temperature is how much? Over temperature means 2.8 over. T1 means 7 degrees Celsius. Convert to Kelvins. 280. 280. Clearly? Clearly? That is equal to P2. P2 means 1 atm. Volume is 4/3. Volume 4/3 pi. Radius means D2 ni. D2 cube. Look here, D2 cube. If I expand the bracket, D2 cube over 8. 2 cube is how much? 2 cube is how much? 2 cube means 8. Over temperature is 27. If you convert to Kelvins, 300. 300. We can convert 8 into Pascal. Look here. Look here. If you convert 8 into Pascal, we want to multiply by 10 to the power 5. If you convert this 1 atm also to Pascal, multiply by 10 to the power 5. What happens is these two cancel out. Therefore, no point of converting to Pascal. So, normally convert to Pascals, but no point. It's get cancel out, no. Right? Okay. Then simplification. Pi cancel out. 4/3 cancel out. Right? Then simplification. Look here. Then simplification. Then if you simplify 2.8. Look here, 2.8. Look here. Nice. 2.8 over 280. You can divide by 1. Sorry. If you divide 2.8 by 2.81, if you divide 280 by 2.8, that's going to be 100. 2 to the power 3. Okay, this 100 cancel out with these two zeros. Then 3 into 8 is how much? 3 into 8 is how much? 24. But I will move this 3 and 8 to the left side. Then we are getting 3 into 8 into 2 to the power cube. That's going to be D2 cube. D2 cube. Look here. Then all are same, no? Then okay, simplification is a problem. Then okay, then whatever here 8 into 8 64. 64 into 3 is how much? 180, 192. Hands up who got 192, 103 answer? Centimeters. Hands up who got 192, 103 answer? Hands up who got 192, 103 answer? Now log value. Log value here 8 into 8 is 64. 64 into 3 is how much? 180, 192. Clear? D2. Tell me now log value. Tell me 19 to right 192 log value is how much? 2 point. 2 point how much? 2 point reply 2 point. 192 log value 2 point. How much? 2833. Noha. Then sorry, Amani. Misra. 2833. The power is what? 1 over 3. The power is 1 over 3 multiplied by 1 over 3. Then we are getting what? Here 0, here 7, 21. 21 means 7. 8 means 6, 1, 0, and T. Tell me anti. 7610 anti. 7610 anti is how much? 7610 anti. Anyone? Anti. I think 5768. Someone, what is the hands up who got the answer? 5.768 centimeter hands up. Diameter D2 is how much? 5.768 hands up. Centimeter hands up. 5.768 hands up. Hands up. Okay, no, right, okay. Now I have to stop the class for today a bit early, okay. The thing is, okay, I hope you understand. Look here. Now one is telling some stories. These days people are blabbering. These days students are, what you call in English, blabbering means blabbering. Likewise, because of the stress. It's because of the stress, I think. Right? One is telling, I'm happy with bio, not other two. I don't really know how should I really study other two. But however I study, no marks. I am not satisfied. Now we all get happy when you get marks, no? Right? You love a subject. Imagine you are loving a subject, right? When you get good marks. But remember one thing I will tell you. Everyone, most of you think biology is very easy. Okay, most of you think like biology is very easy. Right? That's how we all think, no? Because because very rarely only you can check about an evaluation about that lesson, no? Biology. When you are learning physics or chemistry, right, daily you can evaluate where are you, no, little bit, in case based on a question if you could not get the answer, right. When I'm explaining a deep theory, if you couldn't understand, then you can get a kind of understanding evaluation. I don't understand, no. I can't get the answer, no. Right, then I want to improve, no. I think I am not good, no. Chemistry, physics, you get that idea properly, that about you, where are you actually in that lesson, you can get the idea. But biology, you can't get the idea where are you. Because what I understood in bio is, I don't know. What I understood is, mostly every story anyone can understand. Right, mostly it's a description about the concepts, not deep concepts. I think mostly anyone can understand. Just because everyone understands biology, they think like biology is very easy. Because if you understand, mostly other than in an exam, there is no way to evaluate where are you actually. In a class, you can't evaluate. I keep on telling I keep on telling digestive system something, I keep on explaining. You keep on listening and wow, nicely understand your diagram, right, beautiful, everything very clear. You nicely color pen, write the note and all. But that class, if you stayed in that class, can you really evaluate seriously you understood or not? No. Right? In case if they have given an exam, can understand you are where are you. Therefore, people think like biology very easy. But the thing is, remember, biology is the difficult subject to score A. Right? You all know. not physics, not chemistry, right? Even Island First, you all know that Island First they are scoring 99 marks for chemistry, physics. 98, 99 for chemistry, physics. But Island First, when you go and check the marks for biology, 87, 88. If they can score harder subject like physics, chemistry, 97, 99, 98, that Island for scoring 87, 86, 88 marks for biology. There's a gap, 10 marks gap, 10 marks gap. Therefore, therefore now I will tell some ways if possible, right? Okay. Now especially now what you do in that hint classes, get the maximum benefit, right? Do the questions. If you do questions, if you could not get the answer, you get the confident, right? Therefore, hint classes, I will write tomorrow also I'm putting a session. I'll give the idea up to some level. Then when you keep on getting the answers, you get the confident. If you get the confident, automatically you love the subject. That's how that love comes. That's how that love comes, okay? Right, don't worry, I am there. Right, parallelly now the thing is, I want to look at the theory, I want to cover the theories also. Now I am also okay, I will do something. Give some, I will do something. I'll do something, okay, I'll do something. One is telling I hate biology. According to me, we must love all three subjects because ourselves choose the three subjects, right? We ourselves chose the three subjects, right? Yeah, even you love or even you don't love, you want to know do all the subjects properly, okay? Then only can at the end, no point even you got 2A plus and 1 W or 1 S for the subject. No point. You can you ask, is this exam department, imagine all others just got 3 A's, but my story, I got 2A plus, no, right? Since I don't like biology, since I don't like chemistry, since I didn't like physics only, I didn't study that much. Please put me into the faculty, please. Will they give? No need. Therefore, be very careful. Okay, today we will do our class only, right? In my end, this coming year, right? I'm starting a revision class also for your batch, but I want to plan that revision class properly. I will plan properly and separate way. I will tell some stories, okay? Right? I will give this short note point book. I told I will give. I didn't give. I know. That day planner book I told I will give. I didn't give. I know that. I know. Right, I know, but definitely I will give all these stories. Every unit I will give a short note point book. I will give. Sometimes it delays, yeah, it's my mistake only, but I will give. Right, upcoming 1 year you will feel very comfortable, trust me, but follow what I am telling. Hint class homeworks want to do hint class homeworks want to do. Now tomorrow we are writing a small essay question, want to do, right? Likewise, everything you keep on doing, right, then only you can say kind of progress. We'll see. Okay, I don't want to talk every time. I'm talking too much. I'm talking too much these days. How do the Island First can know their marks? Because you go and search your internet. In the internet, they mentioned, right, the top marks, everything they have mentioned. I think they have mentioned how many percentage passed, the top marks, how many people failed as a percentage. Right, what is the max top score? Sometimes when you go and check that Rosa sir's book, in the first page itself, previous means I didn't see the recent years, previous years, that stats he mentioned in this review book also. Okay. Right, okay. Okay, now everyone keep on talking, no? Okay, I love physics, but I hate to do questions. Oh God. It's not mentioned in Rosa sir's book. Did you check all the books? Do you have all the 30 years of books? I need to take a screenshot. Can you please bit move? Oh God. right? Mechanics fast session. Girl starting, don't worry. I'm starting a fast session. Don't worry, girl, very soon. Tomorrow at what time? Even I also don't know. I will confirm. I will confirm. Okay, now? Right, okay, now 9 o'clock, man, I have to start another class. What start another class, okay? Right, anyways, we can talk. If we start talking, we can't do a class, man. That's the problem. Okay? Everyone keep on asking something. So tell a way to study other two subjects effectively. I will tell a way, okay? I'll tell. Give some time. Give some time. Okay. So I am doing 2-day classes to cover the things very soon only, no? If not, why should I do 2-day class for theory? If anyone doing 2-3 classes only? So therefore, want to cover everything quickly. That's why I'm doing 2-day class and I'm really struggling. Right? If not 2 days, 3 days, I'm dedicating for you. Right? And questions, extra hint class and separate stories happening also. No? We'll see. Okay. Anyways, students, then story hands up session is effective answer. Today's session is effective answer. Effective answer. Effective answer. One last thing I'm telling, okay, no matter what happens, don't give up. Even you love the subject too, even you don't love the subject, doesn't matter. Please somehow keep on doing. Keep on doing. Right, that's the way. Okay. Right, you can't tell you don't love just because you don't understand. You can't tell you are not loving that subject. You can't tell like that's wrong actually. Not hurting anyone. Just because you don't love a subject, you can't tell I don't like. Right? Sometimes there are some possibilities that you don't understand. That's okay, but can't tell that I don't want, I don't like. Don't tell like that. Don't tell like that. That's what I can tell. Right? Anyhow, at the end, 3 subjects equal. No, 3 subjects equal. Therefore, be very careful. Be very careful these days. Okay. Okay, right. Okay, now yeah. Then students, then we'll stop the class for now. Right. I won't give up. That's what now I have seen some online people among you. Right. Now I am also noticing some people really good. There are some people. I'm not telling they are brightest. But when I see their work and their thing, I am very happy. But I never revealed them actually still. But I'm very happy. There are a set of online people in the online people, right? Really good level, right? I want everyone to be like that. Okay. But comparatively, you know what? In our class, we are working more. What is the if you ask me what is the plus? We are working more actually. We are doing more questions. We are doing more theory properly. That's our big thing. Okay. Anyways, right? Anyways, okay. Anyways, we have 1 year. Okay. 1 year, we will do something big. Okay. We have 1 year, right? I also plan, right? You also don't give up. Okay. You keep on doing, right? 1 year I will plan. Okay. I'll guide you. Okay. Right. Anyways, we'll stop the class for now. Okay. Then we are meeting once again Thursday. Thursday 6 p.m. we'll start and we'll finish at 11 p.m. Thursday. Okay. Then session is finished. Then good night everyone. I have another class. Today I put another class at night.